Well, welcome everybody. Traditionally, I've done a little bit of a summary just to get things going, sort of what we did over the last few years, last big releases. So I figured I would start off with one of those, try to keep it short, and then we open up to questions. And we have representatives here from all kinds of areas. I represent Algorythm R&D, which we'll see shortly what that means. Tom, sort of systems, programming, compilation, and general sort of system features. Boschko, the cloud Mathematica, and Foltz, the front end and the notebook interface. Then we have Arnaud, which represents, good representative for the pre-release programs, QA, and also a bit of systems programming, so I guess. All right, so let's get going. Our releases are big and tend to get bigger over time as we expand to cover more areas to build this language that in effect is trying to be able to express and discuss and talk about all topics in life. Right, that's the small ambitious. So we did, last year when we met here, we were sort of at the final stages of wrapping up 12.0. It didn't actually come out until April. In that time, we spent a couple of months building these, what we call marketing pages. There are 48 marketing pages, somewhere around 20 examples on each. They tried to summarize and exemplify what's in that release, which includes 11.1, 2, 3, and the gap between 11.3 and 12. If you spend 5 minutes per page, there's about 4 hours to cover it. It's solid. The live presentations, they take about an hour. We've been doing 2 per week. They are going to finish up in November. From April, we've been doing these presentations 2 a week, and we hope to finish up in November. I was gonna do, if we go to those pages, those are actually really good pages. We put a lot of work into it to build those pages. And to just give you a little bit of a summary here, is big enough. So classical areas that we work in, symbolic numeric computation, there's this steady progress of making everything better faster. So things that become better is like limit now do multivariate limits, they're stronger, and things like that. Nth derivative for symbolic n. Asymptotics is a new way of computing. It's a third mode of computing in parallel to symbolic computing, numeric computing, asymptotic computing. We're still rolling out in 12.1. We'll get more features like asymptotic product and the general overall asymptotic that can give you things like asymptotic inverse Laplace transforms and asymptotic series coefficients, things like that. Optimization, big story there is the old from the 70s classification and 80s classification. There's linear optimization and there's nonlinear optimization. That turned out to be kind of largely wrong. It's really convex and non-convex. So the easy problems, the ones that you can solve fast and robust, are convex. The ones that you can't are not convex. Now every time you have a classification that says non-something, it's stupid. So this is just the beginning. It's just a bigger, easy set. The fact that it has non in its name means that it needs a lot more classification and stratification. Nonlinear finite elements. So that sort of completes the roundout for being able to model physical systems with nonlinear partial differential equations. What we're working on now, which you've seen a little bit of, is a symbolic modeling language. It's not ready for 12.1, but we hope to bring you sort of a high-level symbolic modeling language for PDEs, because we have really powerful solvers, but it's really hard to actually feed them with models. So we got to make that simpler. That's a nice problem. We have that problem in many places. Visualization and graphics. Lots of areas. So there's things that we call out, like visualizing the complex domain, as you've seen. And this is one of the first areas where we use a two-dimensional color function. So a color function that goes in both is often tried to represent both the phase of the complex number and the magnitude. So those are two dimensions, right? So how do you do that? Well, you map them to maybe hue and luminosity. You know, there are various mappings, but this is one example of that. That continues with 12.1 has more complex visualization. That sort of gives you a complete stack for complex, what we can do for reals. Geographic, steady progress. Vectors, and in 12.1 there's more. There is density and contour plots over geographic regions. Labeling is this thing that seems simple on the surface, but is surprisingly challenging, and we keep rolling out bits of it and more to come. And in the core, where you can see the beginnings of new domains like scaling functions everywhere, that's one that's been rolling out. You've seen it rolling out for a long time. There's still more to come. The beginnings of a new program, which is rolling out support for uncertainty in our visualization functions. Now think about 150 biz functions. How do you represent uncertainty in all of them? Well, we haven't thought that all through yet, but we're going to roll it out as we move forward, because uncertainty is something that's going to go in kind of deep and big in the language. And also the beginnings of other things like multi-panel plots. There's much more to come with multi-panel, including more in 12.1. Geometry and geography. There's a lot of headroom here for everything, both in geometry and geography. So big pieces of progress here for geometry, in workflows, and robustness. The region wrapper is the thing that kind of simplifies all workflows for geometry. So that was a big deal. There's lots of improvements in little fill-in functionality and making the whole framework more robust. And there's still a little bit more to come, and then we're going to be ready to take next big jumps in geometry once those are. The part of that is to properly, to really do polygons and polyhedra. So polygons, there's a zillion definitions. Like every polygon definition agrees if it's a boundary curve that doesn't intersect. When you have multiple boundary curves, or if you have self-intersecting boundary curves, or both, there is a zillion definition of what is a polygon. Now the same happens when you have polyhedron, where you have a boundary surface. Now when the boundary surface doesn't intersect, or you don't have multiple boundary surfaces, there's pretty much just one definition. When there are many of them, like for polygons, there's a zillion definitions. So we sorted all that out. That's released. There's actually a little bit more to come for polyhedra to complete that out, and you'll see that next. That's an important base for geometry, and a question that's come up many times, like when you're going to have Voronoi for 3D. Well, Voronoi for 3D needs polyhedral cells. Now we have polyhedra for the first time as a primitive, so now we can have it. It's coming out soon. Synthetic geometry, you guys have seen. So it's Euclidean geometry. I personally don't think that this is a useful topic, but because I don't see it being applied to anything. But many people do, and they're really passionate about it, and it's been been picked up, and it's used a lot. It's great, but it's one of those things that could be eliminated from curriculum. Okay, science is good. Uncertainties is a new thing. So uncertainty is a stochastic uncertainty. It's basically a normally distributed variable with kind of a tight bound. And it's represented as a round. We've seen the beginnings of this. There's much more to come. And it's in principle something that will take probably a decade to fully support. So here is the thing. Like if you have uncertainty going into your weather predictions, you want a sort of the data for your weather model. You want the uncertainty to come out in your predictions, and you expect that, right? So then you can think about that in the Mathematica system. Every solver in the whole system now needs to be reworked. Sorry, that takes a little time. If you're going to sort of have uncertainty in and uncertainty out, you know. So, but that is a big deal, because you kind of want to qualify qualify that. Probability and statistics, kind of a little intermediate release with random matrices, lots of robust descriptive statistics and things like that. What you've seen previews of in this conference is spatial statistics, which is coming out next. We didn't talk about much of that. There's a lot of finance, time series, and other things on its way in that space too. Graphs and networks. Again, we're not in an intense phase of graph and networks development, but it's still the best in the world, and we're going to keep on rolling out and keeping it at that level. So that there will be still quite a lot of things, but as I said, that framework is the best in the world. So there's data import export. That's, so for 12, a lot of the data side basically got cleaned up. It's fast, it's complete. Big topics are everyday things like spreadsheets with partial access, modern versions, and performance improvements. But other things that are these very complex data formats, like HDF, which wasn't properly supported all the way out to its full degree, all of that got done and finished off in 12. So I think that the tabular data side is now, I would say, very complete. As far as it goes, there's always more. We could decide whether we should sort of support those, but the ones that we have there, it's at the very core, it's solid, it's fast. Image and audio. So the big theme for both of these things is to utilize machine learning to get sort of these super functions, to get high-level capabilities. So identify cats, important topics, or meows in speech. Which is what we now do in audio. But more seriously, the sort of speech recognition and on all of these things, these high-level functions they're all kind of machine learning based. And machine learning have really sort of brought a revolution to that kind of functionality. And so topically, there is machine learning specifically. So the whole machine learning framework has been optimized. And so for you guys to do anything machine learning in these domains too is very easy, because all those frameworks are really well done for that. There's one vertical, which is microscopy, and you will see more of these for this one and other verticals from image processing going forward, like astronomy and medicine, and so on. Well, machine learning, steady progress, everything. So the neural network framework sort of got a big boost in the 12 cycle. And so one thing is to support all these different kinds of modeling frameworks, like which is supported by all the layers that are there in the neural network frameworks, but also the efficiency of the whole framework, so to support multiple GPU, and to support half precision computation. So normally we would just sneeze at anything less than double in Mathematica. Well, the machine learning guys, they not only do sort of floats, which is not double, they do halves. It's like, woo. So getting performance there is a big deal, and multiple GPUs, half precision, everything to get the performance. And also you've seen in this conference the ability to upload and use AWS to train, because you're unlikely to have the really big sort of GPU setup that you kind of often need for these big training jobs. So all of that is in place, or getting in place, and you can see 12.1 is sort of completing out that cycle, or rounding out that cycle largely. On the high level side, which is machine learning, the big thing there is learned distribution, which allows you, once you have distribution of data, you can say what's not in the data, what's an outlier to data. So that's the big thing. You can also synthesize missing values, because if it's going to follow the same distribution, just generate a random instance from that distribution, and you fill it in. And then the core 3 application domains, image and audio that we talked about, but also natural language text processing. Those are the 3 killer apps currently for machine learning. More to come, but those are the ones for now. And I'm going to sort of teeter out here when we get to the bottom. there's the more interesting things to say about everything here. The last thing here, the Wolfram knowledge base, it's not per se a new knowledge base, but it's documented, which means it's discoverable in a new way. And I think that's really important. I'm not part of developing this, and I've been hounding these guys for years. It's like, gotta give us a way to discover what's mysteriously in this knowledge base. So, and there it is. It's great. Okay, and I apologize for everything I didn't cover. But that's a little bit of a round out to what's happened in 12.